Welcome to week 5 of International Trade Economics. During this week, we will cover chapter 5, which focuses on the Heckscher-Ohlin model. Recall in chapter 3 that trade between nations was motivated by differences internally in the relative productivity of workers when producing a range of products. In chapter 4, the specific factor model considered an additional factor of production, but only labor was mobile between sectors. However, in this chapter we extend the analysis further using the Heckscher-Ohlin model, which considers the pattern of trade that arise when countries have different endowments in terms of the factors of production. These factors of production are mobile between sectors in the long run. After studying this chapter, you should be able to 1. Explain how differences in resources generated a specific pattern of trade. 2. Discuss why gains from trade will not be equally spread even in the long run and identify the likely winners and losers. 3. Understand the possible links between increased trade and rising wage inequality in developed world. 4. See how empirical patterns of trade and factor prices support some but not all of the prediction of the factor proportion theory. Our discussion of the Heckscher-Ohlin model will be structured as follows. Firstly, we will start by looking at the two-factor model, which will address the different production possibilities, the mix of inputs, as well as relationships amongst factor prices, goods prices, resources, and outputs. Secondly, we will discuss trade based on the Heckscher-Ohlin model. Thirdly, we will discuss the two important results from the Heckscher-Ohlin model, that is the Rubczynski effect and the Stolper-Samuelson effect. Lastly, we will discuss the empirical evidence derived from testing the validity of the Heckscher-Ohlin model. The models we have analyzed up to now have placed more emphasis on labor productivity with an assumption that trading countries possess equal distribution of resources or factors of production. This is not always the case, as different countries have various resources in varying quantities. For example, South Africa has more mineral deposits than Lesotho, whereas Taiwan has relatively high skilled labor than South Africa. Based on these differences in labor, physical capital, and other factors of production across countries, the Heckscher-Ohlin model argues for beneficial international trade. Before we start looking at the Heckscher-Ohlin model, let us start by outlining the assumptions of the model. The first assumption is that we have two countries. The second assumption is we have two goods. The third assumption is that we have two factors of production, which is labor and capital. And then the fourth assumption is that the mix of labor and capital used varies across goods. And then the fifth assumption is that the supply of labor and capital in each country is constant and varies across countries. The seventh assumption is that in the long run, both labor and capital can move across sectors, equalizing their return. The seventh factor is that both goods are produced. These assumptions are important as they guide us in understanding the model. Within the Heckscher-Ohlin or factor proportions model, both goods, cloth and food are produced using both factors of production, that is, capital and labor. More so, how much of each good is produced is determined by the production function based on the capital and labor that is employed in each sector. Let us start by looking at the special case in which goods are only produced using one way. Suppose the production of 1 yard of cloth requires a combination of 2 work hours and 2 machine hours, whereas that of food requires 1 work hour and 3 machine hours as reflected by the unit's requirements. Note that these unit requirements are now reflecting the quantity used to produce a given output, not the quantity required as in the Ricardian model. Furthermore, these unit requirements are fixed with no possibility for substituting labor for capital or capital for labor. Suppose further we have an economy that has a total amount of capital available for production of 3,000 units of machine hours and a total amount of labor available for production of 2,000 units of work hours. Based on these unit requirements and the information given above, we can derive the production possibility frontier for this economy. However, the production possibility frontier will be constrained by the available resources. That is, in terms of capital, the total supply of capital cannot be exceeded by capital used in cloth and food production. Likewise, in terms of labor, the labor used in the production of both cloth and food should not exceed the total labor supply. Using these constraints, we can derive the production possibility frontier given that the economy produces both goods subjected to these constraints. Without factor substitution, the production possibility frontier is the interior of the two-factor constraints as reflected by figure 5.1. The maximum food production is 1000 units, point 1, if the economy uses all its capital with an excess of 1000 labor hours. On the other hand, if the economy specializes in the production of cloth, on the other hand, if the economy specializes in cloth production, it will produce a maximum of 1000 units, point 2, with an excess of 1000 machine hours. However, at the intersection of labor and capital constraints, which is point 3, where 500 calories of food and 750 yards of cloth are produced, the economy employs all its capital and labor in the production of both goods. From figure 5.1, it is clear that the economy's production possibility frontier is the interior part of the two constraints with a kink at point 3. This production possibility function reflects that the opportunity cost of producing more yards of cloth in terms of food is not constant. That is, 2 over 3 when the economy produces a low amount of cloth and a high amount of food, or 2 when the economy produces a higher amount of cloth and a low amount of food. This is so because when the economy devotes more resources towards the production of one good, the marginal productivity of those resources tend to be low, so that the opportunity cost will be high. The above production possibility function does not allow substitution of capital for labor in the production process, meaning the unit factor requirements are constant along each line segment of the production possibility frontier. Now let us make our model more realistic by allowing for substitution possibility between capital and labor. As a result of substitution possibility between capital and labor, the production possibility frontier will change from one with a kink to one that is curved or bowed outward as shown in figure 5.2. The bowed out shape reflects that the opportunity cost of cloth increases as producers make more cloth. Given a production possibility curve that is bowed outward, we need to locate a point along the curve where the economy produces both cloth and food. The specific choice or a point of production depends on the prices. However, whatever point the economy is to produce on, the point should maximize the value of production. The ISO value line is a line that shows a constant value of production as reflected by the expression V is equal to PC multiplied by QC plus PF multiplied by QF, where PC and PF are the prices of cloth and food, and QC and QF are the quantities of cloth and food produced. The ISO value line has a slope equal to minus PC over PF. Therefore, the production point of the economy is a point where the ISO value line is tangent to the production possibility curve. At the point of tangency, the opportunity cost in terms of food or producing another unit of cloth is equal to the relative price of cloth. Figure 5.3 illustrates the production point, which is point Q of the economy. The point Q maximizes the value of production given the prices of both food and cloth. As reflected at point Q, the slope of the ISO value line is equal to the slope of the production possibility curve. This means the trade-off in the production of cloth and food equals the trade-off according to market prices. Producers may choose different amounts of factors of production to produce a unit of output. For example, a firm can choose to be relatively more mechanized or employ fewer workers, or they can choose to employ more workers with fewer machines. This means the firm faces a trade-off between the use of capital and labor in the production process of one unit of a good. This input combination is illustrated in figure 5.4. The choice of input combination depends on the wage paid to labor and the rental rate paid for leasing or of capital. If the wage rate is high or increasing relative to rental rates, the firm will choose to produce using more capital, whilst if the rental rates are high or increasing relative to wage rates, then the firm will choose to produce using more labor. Therefore, the ratio of the two-factor prices is crucial in determining the optimum labor-capital ratio in the production process. Please go through the appendix for a thorough explanation of the optimum labor-capital ratio determination. Figure 5.5 illustrates the relationship between wage-rental ratio and the labor-capital ratio in the production of cloth and food. This diagram is drawn based on the assumption that cloth production uses more labor relative to capital than food production, as indicated by the outward shifted CC curve. Based on this, we can say the production of cloth is relatively labor intensive, whilst the production of food is relatively capital intensive. Note that the intensity of a factor in production depends on the ratio of labor to capital used in the production of a good. Therefore, within a two-good model, one good cannot be labor and capital intensive at the same time. The curves CC and FF are relative factor demand curve. Their downward slope reflects the substitution effect. That is, as the wage rate rises relative to the rental rate, firms substitute labor for capital in the production process. In a competitive market, the prices of a good should be equal to its cost of production, which depends on the factor prices. If the wage rises, then ceteris paribus, the good that uses labor more intensive in the production process, price will rise. This shows the importance of a factor price to the cost of production depends on how much a factor is used in the production of a good. For example, if cloth production is labor intensive, the rise in wages will cause the price of cloth to also increase with a great effect as compared to a production process that uses less or fewer workers. From this relationship, we can conclude that there is a one-to-one relationship between the ratio of wages to the rental rate and the ratio of prices of cloth and that of food, as shown by figure 5.6. Figure 5.7 reflects the linkages between prices of goods and the ratio of labor to capital used in the production of each good. Note that figure 5.7 is a combination of figure 5.5 and figure 5.6, with figure 5.5 turned counterclockwise. Given that both goods are produced, if the relative price of cloth is PC over PF1, then the ratio of wages to capital rental rate will be W over R1, More so, the ratio of labor to capital employed in the production of both goods will be LC over KC1 for cloth and LF over KF1 for food. Suppose the relative price of cloth increases to PC over PF2, then the wage rental ratio will rise whilst the labor capital ratio drops. This is so because the wage rate rises. As the wage rate rises, labor becomes relatively expensive. Hence, employers will now substitute labor with capital, causing the labor to capital ratio to decrease in the production of both goods. The conclusion we just had is in line with the Stolper-Samuelson theorem. The Stolper-Samuelson theorem states that if the relative price of a good increase, then the real wage or rental rate of the factor used intensively in the production of that good increases, while the real wage or rental rate of the other factor decreases. Thus, owners of one factor of production gain, whilst owners of another factor are made worse off. Therefore, when both cloth and food are produced, an increase in the relative price of cloth will cause an increase in the wage rental ratio. Thus, wages becomes relatively expensive to capital, hence firms will substitute expensive labor with capital, causing the ratio of labor to capital to drop in the production process of both goods. Therefore, the price increase in cloth raised the real income or purchasing power of workers, and it lowers the real income of capital owners. Now, let us complete the analysis of the two-factor economy by illustrating the effects of an increase in a factor of production on output. According to Rubczynski's theorem, if you hold output prices constant and increase the amount of a factor of production, then the supply of a good that uses this factor intensively increases and the supply of the other good decreases. Let us examine how this happens. Recall that the production of clothes is labor intensive relative to food. More so, both capital and labor are used in the production of food and cloth. Suppose we know the relative price of cloth in terms of food, and these prices are given, meaning they will not change. Furthermore, we know that these relative prices are associated with a fixed wage rental ratio as well as the labor capital ratio in the production of both goods, as we saw in figure 5.7. Now, if there is an increase in labor, which is a factor of production, into the economy as a result of employees searching for good pastures, then that would mean that the labor capital ratio increases. But then how will this economy deal with the increase in labor? This is simple, as it is done by expanding the production of the labor intensive product and contracting the production of the capital intensive product whilst holding the labor capital ratio fixed. Let us use a graph to illustrate how the economy allocates the additional labor to the production of goods in the economy. Remember, for our firm to produce 1 yard of cloth, we need 2 work hours and 2 machine hours. Whilst to produce 1 unit of food, we need 1 work hour and 3 machine hours. So, first, with an increase in labor, if we forgo the production of 2 units of food, we release 2 work hours and 6 machine hours. However, to produce an additional yard of cloth, we need 2 work hours and 2 machine hours. This then leaves us with 4 machine hours unutilized, which we can use to hire 4 new workers in the production of cloth. Therefore, as we continue releasing resources from food production towards cloth production, the economy will produce more cloth and less food, reflecting an expansion bias towards cloth production from the increase in labor as reflected in figure 5.8 by the movement from point 1 to point 2. This outcome proves the Rubczynski theorem. From the previous section, we concluded that an economy with a high ratio of labor to capital produces a high output of cloth relative to food. With the understanding of the two-factor economy production structure analysis and its effect, let us now introduce trade and analyze its effect. Suppose firstly, the home economy has a relative abundance in labor and foreign has a relative abundance in capital as reflected by the expression L over K in the home country is greater than L over K in the foreign country. The above expression reflects that home will be relatively efficient in the production of cloth since the cloth is labor intensive. Hence, home will produce a higher ratio of cloth to food. Likewise, foreign will be relatively efficient in food production as food is capital intensive. Hence, foreign will produce a higher ratio of food to cloth. Secondly, the two countries have the same technology, that is, a given amount of labor to capital ratio used in the production of either food or cloth yield the same output in both countries. Thirdly, both countries have the same taste and preferences, implying that the consumers will behave in the same manner given the prices of the goods in terms of their consumption patterns. Since cloth is relatively labor intensive, at each relative price of clothes to food, home will produce a higher ratio of cloth to food than foreign. Hence, home will have a larger relative supply of cloth to food than foreign, and the home relative supply curve lies to the right of the foreign relative supply curve as depicted in figure 5.9. In the absence of trade, home equilibrium will be at point 1 and foreign equilibrium will be at point 3. When international trade commences between home and foreign, then the relative price of cloth rises at home whilst at the same time it falls in foreign to a point where a new equilibrium world relative price is determined, say at point 2. Firstly, we observe convergence in relative prices with trade. That is, the relative price of cloth rises in the relative labor abundant country and falls in the relative labor scarce country. This outcome is the same as what we concluded in the Ricardian model. Secondly, the rise in the relative price of cloth leads to an increase in the production of cloth and a reduction in the production of food. Thus, the home country will become an exporter of cloth and an importer of food. Lastly, the fall in the relative price of cloth in the foreign country leads to an increase in food production. That is, the foreign country becomes an exporter of food and an importer of cloth. The prediction for the pattern of trade in a two-good, two-factor, two-country model of trade can be generalized using a theorem named after its original developers, Elie Heckscher and Heckscher-Ohlin, that is known as the Heckscher-Ohlin model. The Heckscher-Ohlin theorem states that a country that is abundant in factor exports the good whose production is intensive in that factor. This theorem can be extended in a realistic case with many countries, many factors of production, and a number of goods as a correlation. That is, countries tend to export goods whose production intensively use the factor of production with which the country is abundantly endowed. Now, let us look at what happens to the distribution of income in our model given that the two countries are trading. Recall from the previous analysis that an increase in the price of cloth will affect earnings of labor and capital through raising the purchasing power of owners of labor whilst decreasing the purchasing power of capital owners. In short, labor gains whilst capital loses. In terms of trade, owners of the abundant factor in the country gains while owners of scarce factor are made off. Since the abundant factor is in the exporting sector and the scarce factor is in the importing sector, then trade benefits the export industry whilst hurting the import sector. This outcome is the same as what we concluded in the specific factor model. However, the only difference between the two models is that the temporary nature of the specificity of the factors in the long run Heckscher-Ohlin model. This implies that the income distribution effect caused by labor and other factors of production are temporary or transitional problems within the Heckscher-Ohlin model. For example, if we look at the United States trade with the rest of the world, we will see that the United States is abundantly endowed with highly skilled labor whilst low skilled labor is scarce. Therefore, trade tends to benefit highly skilled labor and hurt low skilled labor, not just temporary but on a sustained basis. Nevertheless, changes in income distribution happen not just with trade but when there are economic changes such as changes in technology, changes in consumer preferences, exhaustion of resources, amongst others. However, some economists blame technology and the premium paid on education as the major causes of income inequality in the United States. See the case study on North-South trade and income inequality. Despite the losses experienced with trade, it is beneficial to trade since losses can be compensated in one way or the other as the gains are far more than the losses from international trade. Trade, according to the Heckscher-Ohlin model, predicts that factor prices equalize between trading partners. Remember, before trade in the labor-abundant country, cloth is relatively cheaper, whilst food which is capital intensive, is relatively cheaper in the capital abundant economy. As a result of the differences in the prices, the rewards to the factors of production also differ. However, with the production of both goods and international trade based on the Heckscher-Ohlin model, the output prices of both goods equalize, leading to the equalization of the factors of production. This happens simply because of the exchange of goods as well as an indirect exchange of factors of production. Therefore, as trade increases, the demand for cloth in the whole country, it also indirectly increases the demand for labor, thus increasing the wage rate for labor. Although the predictions of the Heckscher-Ohlin model in terms of the factor prices is appealing in the real world, factor prices does not fully converge or equalize. To understand why this is the case, let us start by looking at the crucial assumptions of the Heckscher-Ohlin model that explain the factor price convergence. Firstly, both goods must be produced. In the real world, countries might specialize purely in the production of a good in which they have factor abundance. Hence, for both goods to be produced, both countries would have similar relative factor endowments. Thus, factor prices need not be equalized between countries with radically different ratios of capital to labor or skilled to unskilled labor. Secondly, technology must be the same. In the real world, we observe that different countries possess different technologies. As a result of differences in technology, there will always be variations in the productivities of the factors of production. Therefore, the wage or rental rate paid to these factors of production also differs. Thirdly, trade equalizes the prices of the goods. In the real world, price of goods do not converge fully due to barriers to trade such as transport costs, tariffs, and trade restrictions, amongst others. These barriers to trade increase the cost of trading, which will lead to a decrease in the volume of trade. Lastly, our model assumes its prediction based on the long run, but even in the long run, after opening up the economy for trade, factors of production might not quickly move to the industries that intensively use the abundant factor of a country. Therefore, within the short run, wages and rental rates may differ between countries as factors of production will be rewarded based on their productivity in the specific industry that they are employed. Therefore, the differences in factor abundance are the basis of trade in the Heckscher-Ohlin model. More so, as we just concluded that with differences in factor abundance, trading of goods also imply trading of factors of production indirectly. This is a powerful prediction of the Heckscher-Ohlin model. However, because factor prices do not converge fully, empirical support of this prediction is very weak. This is not to say that the Heckscher-Ohlin model does not help in explaining trade, as it does play a crucial role. Let us look at a few empirical studies. The United States is one of the countries that continue to be ranked high in terms of capital-labor ratio. Based on that, one would expect, in line with the Heckscher-Ohlin model, that the United States must export capital-intensive products whilst importing labor-intensive products. Surprisingly, the study made by Wesley Leontief found that the United States exports were less capital intensive as compared to their imports. This outcome was the opposite of what the Heckscher-Ohlin model could have predicted, and it is known as the Leontief paradox. The table 5.2 shows data illustrating the Leontief paradox. The first two columns shows that in 1962, the US exports were produced with a lower ratio of capital to labor than the US imports. Nevertheless, other comparisons were in line with the Heckscher-Ohlin model, as the US exported more skilled labor-intensive products than they imported. The existence of the Leontief paradox has been argued to be neither the consequence of the data specific to the period under Leontief study nor the violation of the same technology assumptions in the Heckscher-Ohlin model. Furthermore, another study was done by Bowen, Lima, and Skeikaukas in a bid to test the validity of the Heckscher-Ohlin model on 27 countries. However, their finding also confirmed that the Leontief paradox does exist on an international level. They also suggest that the existence stems from the violation of the same technology assumption. Another study by Daniel Treffler, The Case of a Missing Trade, further confirmed technology differences as the cause of differences between actual or observed volume of trade and those predicted by the Heckscher-Ohlin model. In his view, technology tends to influence the productivity of the workers, hence their value of labor services will also be influenced. This simply means a country with a high level of technology as well as high value of labor services would not necessarily import a lot of goods from other countries with low technology and low value of labor services. Another study by Davy and Weinstein argued that if the assumption of the same technology together with the fact that trade is costless are relaxed, then the predictions for the direction and volume of factor content of trade line up well with the empirical evidence and ultimately generate a good fit. On the other hand, the comparison of the exports of labor abundant skill scarce nation in the developing world and the export of skill abundant labor scarce nations do fit the prediction of the Heckscher-Ohlin model. Therefore, a key prediction of the Heckscher-Ohlin model is that changes in factor abundance leads to biased growth towards sectors that use that factor intensively in production. This is evidenced by the growth in Asian economies, that is, South Korea, Taiwan, Hong Kong, and Singapore. Thus, as the supply of skilled labor increased, they increasingly specialized in the production of skill-intensive goods. The changes over time prediction of the Heckscher-Ohlin model hold for the experience of China over the last 3 decades, in which its high growth has been associated with increases in skill abundance. Furthermore, looking at China in the most recent years, their greatest share of exports is concentrated in skill intensity sectors, which in the earlier years were concentrated with low skill intensity sectors. Trade in the real world does not reflect factor price equalization across trading nations. Furthermore, if we test for pure Heckscher-Ohlin model maintaining its assumption, we will observe very weak evidence of country factor abundance trade. However, if we use a less restrictive version of the Heckscher-Ohlin model, the empirical tests confirm the validity of the model. More so, the trade of developing and developed nations also fit the model quite well. Apart from the mixed result observed from the empirical test, the Heckscher-Ohlin model remains vital for understanding the effects of trade, especially on the distribution of income.